What is up, mathletes? Care to math? You know I do. That's why I am back with another video lecture. Here we're going to talk about solving a radical equation that has rational exponents. However, now we got an odd index, an odd exponent, so we're not going to have to worry about turning this into an absolute value equation. So let's go ahead and let's attack this thing. Remember, my goal is I want to isolate this expression with the rational exponents. So I'm going to do that, put in blue here. And in order to do that, I have to first subtract the 1 from both sides. So I'm left with 3 and then x plus 1 to the 3 over 5. What does that equal to now? That's equal to 24. Is the expression I'm looking to isolate isolated yet? No, because if you look on the outside of this box, there's a 3 right there. Not cool. We got to get rid of that. So I'm going to divide both sides by 3. Don't you dare add it, subtract it, multiply it. The only thing you can do is divide. That's why I did it. So I'm left with x plus 1 to the 3 over 5 is equal to 24 divided by 3. Anyone got it? What do you think? It is, yep, I heard it, 8. So we get 8. And now, if you remember, to get rid of these rational exponents, I just have to do a little something I like to call the flipperoo. I have to take my 5 and flip it up to the top. I have to take my 3 and flip it down to the bottom and multiply them by the reciprocal here. And I'm going to do it to both sides. So what that does is on the left side, 3 times 5 is 15, and 5 times 3 is 15. So that means I get 15 over 15, or my new exponent is just going to be x plus 1 to the first equals 8 to the 5 over 3. And really, I don't even need to write it this way. I just wanted to show you what happens to the exponent, so I don't even have to write that. Now, here's the deal. I have an odd index of 3. I have an odd exponent of 5. Why is that important? Because in a previous video, you may have seen that we had an even index and an odd exponent. We would have had to turn this into an absolute value equation. In this case here, we have an odd index and an odd exponent. So that's great for us. We can just go ahead and solve this. We don't have to worry about turning it into an absolute value equation or anything like that. We can just go for this and solve. So I'm going to leave this as x plus 1 on the left side, and I'm actually going to simplify this 8 to the 5 over 3. Right? My index is 3, like I decided over here. My exponent is 5. So this is going to turn into the cube root of 8 to the 5th. And 8 to the 5th is beep, boop, boop, beep, 32,768. Don't be impressed. All I did was I plugged that into my calculator. I didn't do the whole beep, boop, 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 beep thing. I didn't know it off the top of my head. Don't worry. So yes, this is the cube root of 32,768. And what I'm going to do now is just, solve this out. So I get x plus 1 is equal to the cube root of 32,768 is beep, boop, boop, beep. That would be 32. Again, don't be impressed. Just use this thing called a calculator. All right. So now, my friends, this is just what we call a one-step equation. One-step equation means there is, count them, one step. So all I have to do is subtract 1 from both sides, and I get x equals 31. And that is my answer. That is how I solve this. I'm not going to make us check this for extraneous solutions. Although if I was going to do that, all I would have to do is take this x equals 31 and plug it into x right here and see if I got a true statement. If I got a number equals a number and then the same number, it's a true statement. If I got one number that equals a number that it doesn't actually equal, I would have an extraneous solution. So thank you for tuning in here. hanging with me. I hope this helped. And if you have any questions, please let me know.